Welcome to Bidnik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Bidnik Tutors. Excellence is our watchword.
Hope you are doing good. Well, we're happy to see you once again. Thank you we are at 36 subscribers now. Please kindly help us to share. Kindly help us to download. Kindly help us to watch so that you can become a partaker of this, because the knowledge has started. So we are going to spread it across the world for every one of our viewers. So thank you for those who have been commenting, those who have been following us. We appreciate you. We are also trusting you to join our Telegram channel. The channel is there because subsequently we'll be sending questions that the solutions will also be sent through the Telegram channel. Although then the correction will also be done through the assignment there. So please join our Telegram channel. Through our Telegram channel, you can get your feedback, you can tell us your observation concerning our videos and many other things. So please kindly join our Telegram channel. Just search for Bidnik Tutors on Telegram channel. It can accommodate as many numbers as possible. Just trust God in our lives so that you can partake of it. I'm still myself, Engineer Nawi Adebayo. So we'll be continue with index notation part 4 this morning. Index notation part 4. So we trust God that we shouldn't have more than 2 classes again on this index notation so that we can move to another topic. And we can assure you next week we'll also be starting the logarithm of SS1 and 2 together. Logarithm of greater than 1, logarithm of less than 1, so that it can be the basics. Then from there we'll move to circuit geometry 1 and many other topics. So join us as you follow us up. Thank you. We love you all. Thank you for subscribing. Please still subscribe so that you can still receive more of our notification whenever we upload our videos. We love you all. Thank you for the viewers. We are grateful. So this morning, there's a question on our index notation part 3 that was wrong. So we just want to do the correction of that. We later realized that there was an error of negative that we made. So we want to do that again. You can still check back. So we have told to solve that question. We are told to solve 27 raised power x plus 2 is equal to 9 raised power 2x. So from here, we have 9 raised power 2x. So that's where there was an error with the question. So this base 27, base 9. This power x plus 2, power 2x. So we ensure that both of them become the same base. So here will be 3 raised power 3, bracket x plus 2, 3 raised power 2, bracket 2x. So from here, we can now say 3 raised power 3 times x, 3x plus 6, 3 raised power 4x. So that's with the multiplication there. So the same base, we now equate the power. We can now say 3x plus 6 is equal to 4x. 3x minus 4x is equal to minus 6. Because the same base here, we are equating the power. The power here, we use 3 to multiply x. We use it to multiply 2. That will be 3x plus 6. Then 3 raised power 2x, that will be 2 raised power 4x. So we now have the same base, we equate the power. So we now have 3x plus 6 is equal to 4x. We bring the positive here, become negative. Positive here outside become negative here. So 4x from 3x is minus x is go to minus 6. Divide both sides by minus 1. Because the coefficient of x there is minus 1. So this cancel this to become plus, this cancel to become plus. We now have x divided by 1, x, c divided by 1, 6. So our answer is 6. So that's the question that we had issues with in the former one. So that is resolved. So we want to look at some other questions there. Here, as we proceed. Thank you. Please take time, just look at it and study. Work to solve it. So in dealing with this, we discovered that 10 raised power 9 times 10 raised power 12. So when you are given any question in indices, you are going to know the laws, as I've said in previous videos. Then the knowledge of the law is what you are going to use to apply it. If you understand the law, your brain knows how to pick the right law among the laws of indices. That will show that you've been able to comprehend the laws of indices. So for me now, I know I'm applying multiplication law because I have a base, common base, then I have power. Then multiplication means I'm going to add. So I'll just start from here. 10 raised to power 9 multiplied by 10 raised to power 12. Please don't make this mistake. Don't start with this index notation part 4. Maybe you are just coming across the video. Don't start with this index notation part 4. Please start with index notation part 1. Be patient, watch part 2, watch part 3. Please, if you are the type that can't use to a long video and you have a child, please just watch. Be patient after watching, then download. Because that will be of help to you. So don't say, oh, it's too long. No. The reason is that we want any topic we teach here, even if your child misses any classes in his normal school, you should still be able to do those topics in white neck one, even including the school internal examination. Because by the grace of God, on this topic, I make use of new general mathematics, comprehensive mathematics, and essential mathematics with past question involving tonal, publisher, and platinum. Just to tell you that it is well seasoned, then including hidden fact mathematics, almost 6 textbooks. So by the grace of God, as engineers, we are researchers. Whatever we are communicating within the science world, engineering is an application of science. We are communicating within the science world. We want to ensure that we give it to you effectively. In such a way, in the next 5 years, even your children that will still grow up later can easily have access to this video, and it will be a blessing to them. So those are the advantages. That's why we are trying our best to give you in details. Other people's videos may not be much, but one choose to be much because we choose to make it a mini school, an online mini school, and which means your children can survive it. They can survive it within the atmosphere. So those are some of the things there. Thank you. So you're applying this. You go to the first one, as I said, go and watch the videos on index notation part 1, part 2, part 3. Then before we come to this, it's just the stages. So the same base we add the power. That will be 10 raised to power 9 plus 12. Because for multiplication, we had. And that will be 10 raised to power 21. 10 raised to power 21. And that's your final answer there. So for B, we have 18 x raised to power 8 divided by 6 x raised to power 5. So we open this up in such a way that we will say 18 times x raised to power 8 divided by 6 times s raised to power 5. So from here, we can now do our work. We are going to pick 18, use the division by 6, x, the division by 5. So we just say 18 divided by 6 multiplied by x raised to power 8 divided by x raised to power 5. So we pick 18, use the division by 6. So we pick this two multiplication, we'll take it as 1 here. Then s raised to power 8 divided by s raised to power 5. So I'm going to divide this normally. 6 divided by 18, that's 3. Then multiply by, then apply division law here. I'll pick the common base, 8 minus 5. So in division law, we subtract the power. So here we have 3 times s raised to power 3. So that's the illustration there. Then at the end, we now have 3x raised to power 3. I'm sure that illustration is clear to us. So take note of things like this as we journey ahead. So then for C is also the same. We have x raised to power minus 4 divided by x raised to the power minus 5. And that's equal to, we put the common base, x minus 4 minus 5. So at the end we have x raised to the power minus times minus become plus. That's minus 4 plus 5. And that's x raised to the power 1, which is equal to x. So that illustration is clear. That illustration is clear. So that's that. We'll proceed to this D, E, and F later, subsequently, as we proceed that side. Clean the board. Multiply by t raised to power 2, multiply by t. So here, we know they are all the same base, t. So you apply multiplication law. This means t raised to power minus 4 multiplied by t raised to power 2. Then when you see a base where there is no power, it means raised to power 1. But if it is 0, -1, or values like 2 and above, they will always put it there. So you have to indicate t raised to power 1. But when it is raised to power 1, they won't put it there for you. So we pick the common base we had, minus 4 plus 2 plus 1. So minus 4 plus 2, that's minus 2 plus 1. Yes, t raised to power minus 4 plus 2, that's minus 2 plus 1, minus 1. So because minus 4 plus 2 is minus 2 plus 1 is still minus 1. So the answer is minus 1, or you can also say or. You know, we told you, if your power is negative, it means t over 1 raised to power minus 1 is still the same thing. You know, like when you have 3 as whole number, you can have 3 as 3 or 3 over 1. So because the power here is negative, there will be an interchange of the fractional base. The denominator of the fractional base will go up, the denominator will come down. So here will be 1 over t raised to power 1. So here is equal to 1 over t. So pick the common here, a. Here will be a raised to power minus 4 plus 4, which is equal to a raised to power 0, which is equal to 1. This is 4, this is 8, this is 2. So we can ensure all of them are in base 2. So here will be 2 raised to power 4 multiplied by 1 over 8 is 2 raised to power 3. Then raised to power minus 1 multiplied by 2 raised to power 2. Then 0. You know it has 0 on its head before. So here when we bring it up, it becomes negative, because that's for the 0 index law. So these 2 raised to power 4 multiplied by 2 raised to power minus 3, then raised to power minus 1, then multiplied by 2 raised to power 0. So at the end, you know, minus, we apply product law with this. Minus 3 times minus 1. These 2 raised to power 4 multiplied by 2 raised to power minus 3 times minus 1. Then this 2 raised to power 0. So here's 2 raised to power 4 multiplied by 2 raised to power 3 multiplied by 2 raised to power 0. So at the end, we now have 2 raised to power 4 plus 3 plus 2 plus 0, which is 2 raised to power 7. Which is our final answer. So those are the ways there. Just on your own, after going through it, you realize that, oh, you don't still understand. Just rewind back the video and hear me again. It's very simple. It's as simple as that. Solve this. So in dealing with this, when you are told to simplify this, here means 6 times a raised to power minus 4. We just open this up. So we just want to take away the negativity of the power of, or of the base of a. So here will now be 6 times a, you know, here is a over 1 only before raised to power minus 4. Just as I told you that there's always a base, there's always a 1, a fractional 1 under a whole number. So there will be an interchange because this is this. So here we now have 6 times 1 over a. Then when you interchange, automatically the power will change. That will be minus 4. So here will now be 6 times 1 over a raised to power 4. So this over 1 also. Let's make this over 1 so it can be more easier. So then we have 6 times 1, that will be 6. 1 times a raised to power 4, that will be a raised to power 4. So that's that for that. So it's as simple as that. If it's not still clear, just watch over again. Move back a little bit. B, if we have 3 x raised to power 3, y raised to power minus 4, z raised to power minus 2. So here, very simple. We just ensure the negativity leaves this one. This will be 3 times x raised by 3. Then this will be 1 over y raised by 4. Multiplied by 1 over z raised by 2. You have to jump a step there since you've been following these things. So here will now be 3 x raised by 3. This over 1 over y raised to the power 4 z raised by 2. And that's our final answer there. So it's as simple as that. The negativity of this power, that's what makes this y to become a base, a fractional, a denominator base. Although it's a numerator here, z to become a denominator base, and the power goes along with it down. Then the negativity of the power goes away. And so that's all. We are going to do CDE too. So here will now be 5 times s squared times y multiplied by 2 times s to the power 5 times y squared. We open it up. We open each of the numbers up with the variable. So from here we can now say 5 times 2 times s raised to the power 2 times s raised to the power 5 times y raised to the power 2. So we'll make this one, we know already. So here's 10 times s raised to the power 2 plus 5 multiplied by y 1 plus 2. So from here we have 10 times s raised to the power 7 times y raised to the power 3. So at the end, we now have our final answer is 10 x raised to the power 7 y raised to the power 3. And that's our answer. So just pure multiplication now. Thank you. So we move to D. Open up is 12 times p raised to the power minus 5 times q raised to the power minus 6 divided by 3 times p raised to the power 8 times q raised to the power 10. So here will be 12. So we place 12 divided by 3 multiplied by p raised to the power minus 5 divided by, so we are using the division divided by, because we are taking 12 divided by 3, p divided by minus by 8 multiplied by q divided by q raised to the power 10. So here will be p raised to the power 12 divided by 3, just as we said, 12 divided by 3, p raised to the power minus 5 divided by p raised to the power 8, then q raised to the power minus 6 divided by q raised to the power 10. So p raised to the power 8 divided by, multiply, with this multiplication, then this will now be q raised to the power minus 6 divided by q raised to the power 10. So without illustration, we are good to go. So we can now say 12 divided by 2 is 4. Multiplied by, here is p raised to the power minus 5. The division, we subtract the power, minus 8. Multiplied by q raised to the power minus 6 minus 10. So here will now be 4 times p raised to the power minus 13 times q raised to the power minus 16. So if that is done, so at the end we have 4p raised to the power minus 13 q raised to the power minus 16. And you can later rewrite it out like this. So it can become 4 times 1 over p raised to the power 13 times 1 over q raised to the power 16. So here will be 4 over p raised to the power 13 q raised to the power 16. That's one answer. You can decide to stop here and decide to stop there. So it depends on what you want. I'm sure that is so. So dealing with this, if we have a, that's 1 over 8 raised to the power 2x minus 2 raised to the power x minus 1. Okay, here we have the, that's 1 over 8 is 2, is 1 over 2 raised to the power 3. Open bracket 2x minus 2 raised to the power x minus 1. Yes, 2 raised power minus 3, open bracket, 2 raised power x minus 2 raised power x minus 1. So here we'll multiply this, here we'll multiply this. So here will be 2 minus 3 multiplied by 2 raised power x minus 2 minus 3 multiplied by 2 raised power x minus 1. So just as we said, 1 over 8, 1 over 2 is power 3, open bracket 2 is power x minus 2 is power x minus 1. 2 is power minus 3, open bracket 2 is power x minus 2 is power x minus 1. We now use it to multiply this minus this to multiply this. So here will be the same base equal to the power 2 is power minus 3 plus x minus 2 is power minus 3 plus x minus 1. So which will be 2 raised to power x minus 3 minus 2 raised to power minus 3 plus minus 1 plus x. That's because minus 3 plus x is the same thing as x minus 3. So x2 raised by x minus 3 minus 2 raised by minus 4 plus x. So here will now be 2 raised by x minus 3 minus 2 raised by x minus 4. So which is our final answer. So that's just the illustration there. We are applying multiplication. Use this to multiply this. To multiply, we open this up. This will be 2 raised by minus 3. We will now use it to multiply this. Then we apply multiplication law. Multiplication law here. Then here is 2 raised by minus 3 plus x minus 2 raised by minus 3 plus x minus 1. That will be 2 raised by minus 3 plus times minus is minus 4 times x is plus x. So at the end we have minus 4 plus x, 2 raised by x minus 3. So at the end we have x minus 4. So that's for A. If you look at B, we want to resolve B. Our B is 27 raised by x minus 1 multiplied by 27 raised by 1 minus x. So here we just put of them can be of base 3. So this 3 raised by 3 x minus 1 multiplied by 2 raised by 3 1 minus x. So 2 raised by 3x minus 3 multiplied by 3 raised by 3 minus 3x. The same base. That's 2 raised by 3x minus 3 plus 3 minus 3x. Just the multiplication law there. We use 3 to multiply this, 3x minus 3. 2 multiply the 3 minus 3x. So we now bring it together, 3 raised by 3x minus 3x minus 3 plus 3, which is equal to 2 raised by 0, which is equal to 1. So that's that. So we want to touch some simple exponential equations whereby we deal with this. We have here solution. You have A. A is x raised by 1 over 3 is equal to 5. Take note of something. Whenever we have a power of a variable x as fraction, we'll find a means of neutralizing this power, this fractional power on top. The fractional power on top, we find a means of neutralizing it. This 1 over 3. So the best we will do is that we multiply this power by its reciprocal. The reciprocal of 1 over 3 is 3 over 1. And the same reciprocal we use to multiply these two. That will be x raised by 1 over 3 multiplied by 3 over 1 is equal to 5 raised by 1 multiplied by 3 over 1. Let's say it is 1 over 4 here. I would have multiplied by its reciprocal 4 over 1. Here will also be 4 over 1. So x is equal to this cancel this power 1, then 5 raised by 3. So x is equal to 125. Because 1 times 3 is 3. And x is equal to 125. So that's clear. we'll now move to B. If we B under B, if we have 3x raised to power half is equal to minus 27. So what we need first is for us to divide both sides by 3. So x raised to power half is equal to minus 9. X raised to power minus half multiplied by, here now it will be multiplied by minus 2 over 1. That's the reciprocal of the power of minus half. That will be minus 2 over 1. Then multiplied by is equal to 9 minus 9 multiplied by minus 2 over 1 over 1 or 1 times, because this is minus 9 is power 1 minus 2 over 1. So automatically that is settled. This cancel this. So we now have, because this one has a negativity, x is equal to minus 9 raised to power minus 2. So x is equal to 1 over minus 9 raised to power 2, which is equal to 1 over minus 9 multiplied by 1 over minus 9, which is equal to 1 over 81. Because we divide both sides by 3, we have x raised by minus half is equal to minus 9. Then the power of x is minus half. So minus half multiplied by minus 2 over 1. So this cancels this. Minus times minus, we have x. Here will now be minus 9 raised to power 1 times this. Now 1 times minus 2. So minus 9 is going to the same. Minus 9 is power 1. Yeah. So minus 9. That will be 1 times minus 2 over 1. So we now have x is equal to minus 9 raised to power minus 2. Because this one is negative, this will be 1 over minus 9. Then multiply by this 1 over minus 9 times 1 over minus 9. That's 1 over 81. This 5 is power 5 is power 2. The 5 is power 2 will give us 25. So the same base will equate the power. So x is equal to 2. The same base will equate the power. The power is s and 2. So the power, let's make this into power s. We're getting as saying here is 7.125. It's you saying moving the decimal point here. 7.125. Move it 1, 2, 3. So that's 8 raised to power x times 125 times 10 raised to power minus 3, the form of a standard form. So 8 raised to power x is equal to 125 times, here will become 1 over 10 raised to power 3 for the zero index law. So place this over 1, this 8 raised to power x. 8 raised to power x is equal to minus 0.125. 8 raised to power x is 0.125. We now discover that we say 8 raised to power x is equal to, here's 1, 2, 3, that's 125 times 10 power minus 3. When you are converting this decimal point, you move it to here. So, and when you're moving from the left to the right, it will be 1, 2, 3. So that will be 125 times 10 raised to power minus 3. And 8 raised to power x is equal to 125 times 10 raised to power minus 3. And that will be 8 raised to power x is equal to 125 times this 10 raised to power minus 3 will become 1 over 10 raised to power 3. So 8 raised to power x will be equal to 125 over 1000. Then 8 raised to power x is 5 here, 125, 25, 5 in 1200, 5 in 25, 5 in 240. We now have 8 raised to power x is equal to 5 over 40. That's 1 over 8. So we have 8 raised to power x is 1 over 8 raised to power 1. So 8 raised to power x is equal to 8 raised to power minus 1. We now have 2 raised to power 3 times x is equal to 2 raised to power 3 times minus 1. And you multiply this. We ensure that both of them are of the same base. That's why you can also here say x is equal to minus 1 is allowed. So yeah, and then we now have 3 raised to power x is equal to minus 3 divided by 3. X is equal to minus 1. From here too, you can just bring your work down. 8 raised to power x is equal to 8 raised to power minus 1. So x is equal to minus 1. It's still the same thing. So p raised to power x is equal to 1 over p raised to power minus half. So we'll take this up. Is it clear? This will be p raised to power x is equal to p raised to power half. So we take this up, and the negativity of this base but the power of the base will go away. So x is equal to half. The same base will equate the power. It's very simple. This over 1. We can just take this one, do something here, take this one up. This y raised by x is equal to y raised by minus 3 divided by root y, which y means half. Half, anything is 1 over 2 power is ordinary root. So y raised by x is equal to y raised by minus 3 divided by y raised by half. So we apply division law here. Y raised by x is equal to y raised by minus 3 divided by y raised by, it will be minus 3 minus half. And that will be minus 3 half. So we have y raised by x equal to y raised by, this is over 1. So if on a rough sketch, if you have minus 3 minus half, this over 1, the LCM will be 2. 2 divided by 1, 2 times this minus 6. 2 divided by 2, 1 times this 1. So at the end we have minus 7 over 2. Because minus 6 minus 1 is minus 7. So y raised by x is equal to y raised by minus 7 over 2. So x is equal to minus 7 over 2. So g. So that's that. In an illustration like this, we are multiplying, apply multiplication law here, we apply product law over this, we now apply division law. Then we now compare with VS at the left. That's how we'll solve that. V raised by x is equal to, here will be 4th root v raised by 5. So the root of 4 here is always fraction. When you see something like maybe root 9, it's more than like saying 9 raised to power half. When you see something like 3rd root 9, in indices it's 9 raised by 1 over 3. Because we believe that the denominator will be the root, the denominator will be the power, and 1 have no effect. So it's more or less like we're saying 3rd root 9 raised by 1. And you know it should remain as 3rd root 9. So that's just the illustration there. So here will now be v raised by 5 raised by 1 over 4 multiplied by v raised by minus 1 over 4. Then this is over, here will be v raised by 1 over 3, then raised to power 2. Because the third root is going to like this. So here will now be not. So here is v raised to power x is equal to we will apply multiplication on product law here. 5 will multiply 1. That will be v raised to power 5 over 4 multiplied by v raised to power 1 over minus 1 over 4 over, then here will now be this multiplied by this. That will be 2 will multiply 1. That will be v raised to power 2 over 3. So here we can now say v raised by x is equal to v raised by minus 5 over 4 plus minus 1 over 4. This is 5 over 4, sorry about that. Over, you had, so here's v raised by 2 over 3. So v raised by x is equal to v, here plus minus, that will be 5 over 4 minus 1 over 4 over v raised by 2 over 3. So v raised by x is equal to v, subtract here, that will be 4 over 4, v raised by 2 over 3. So go subtract 5 over 4 from that, we'll have that raised by x. Now this 4 over 4 is the same thing as saying v raised by 1, for this cancel this here, over v raised by 2 over 3. So v raised by 1 divided by v raised by 2 over 3. So v raised by x is equal to v raised by 1 minus 2 over 3. So it's equal to v raised by, we do 1 over 1 minus 2 over 3. LCM is 3. 3 divided by 1, 3 times this 3. 2 divided by 3, 1 times this 2. So that's equal to 1 over 3. So v raised by x is equal to v raised by 1 over 3. So s is equal to 1 over 3. So that is done. The same base equate the power. So 5 is power 2x is equal to 1 over 625. So this will be here. We now have this 625 is 5 is power 2s is equal to 1 over 5 is to the power 4. 5 is power 2s is equal to 5 is power minus 4. So we bring 5 is power 4 a denominator. Bring to become a numerator, the power of that denominator will be negative. So 2x is equal to minus 4. We have side by 2. Cancel this. So x is equal to 2 here 1, 2 here 2. So minus 2. So we can now say from here, we were told that 1 over 4 of 64 is per s is equal to 16 is per 3s. So in dealing with this, we can now say 1 over 4 of yes, of here means multiplication. 64 is 4 is per 3s is equal to 4 is per 2 is per 3s. So here will now be this is over 1. So we can ensure this one goes up. This will be 4 is per minus 1 multiplied by 4 is per 3s is equal to 4 is per 2 times 6 3s, that's 6s. So here will now be we apply multiplication law here. 4 is per minus 1 plus 3s is equal to 4 is per 6s. So the same base equate the power minus 1 plus 3s is equal to 6s. So we bring this here, we can bring this here and take this here. So here can be minus 1 is equal to 6x minus 3s. So because from here, we know that 4 is to here's more or less like saying 4 is power 1. So 4 is power minus 1 multiplied by 4 is power 3s is equal to 4 is power 6s. So here's minus 1 plus 3s. So we bring this there, that's negative. Minus 1 is equal to 3s. That goes by 3. 3. So from here, we can now say that minus 1 over 3 is equal to s. That's our answer. The same base. So we can now say from here, we can now say that here's 3 is power 2 open bracket x minus 3 is equal to 3 is power 3 open bracket x minus 5. So the same base equate the power. So here will be 2 open bracket x minus 3, 3 open bracket x minus 5. So here will be 2x, 2 times 3 minus 6, 3x minus 15. Here will now be 2x minus 3s is equal to minus 15 plus 6. Here's minus x is equal to minus 9. That is said by minus 1. So x is equal to 9. Cos minus cancel minus x minus cancel minus plus, that will be 9. Here, since it's 3 over 4, a base that has a power like this, we ensure whatever we have here to be of raised to power 4 and 3 or 3 and 4. So here 64 means 4 raised to power 3. This is 4 raised to power 3 over 3 raised to power 3. This is 3 over 4 raised to power t minus 1. So the best thing we could do, we can bring this one here. Here will be 4 over 3. Since the power are the same, we can pick a common power for both of them because the power of 3 outside, they have power. It has power over this. That's why power over the denominator. It has power over the denominator here of the base. So here will now be 3 over 4 is power t minus 1. So what we can do here, we can do either of the two here. We can transfer this again, we can interchange this so that this can carry a negative power. So this should be in such a way that we can say We interchange this. This will be 2 raised to power 4. Then automatically it's going to carry a negative 1. Then multiply by 3. Because we interchange this, we assume that both of them can be, let's say, raised to power 1. So when we interchange, it become negative 1. Then we'll now use it to multiply the 2 here. Then 2 raised to power 4 raised to power t minus 1. So at the end, we now have 2 raised to power 4 raised to power minus 3, because minus 1 times 3 is 2 raised to power 4 raised to power t minus 1. So the same base equated power, this will be minus 3 is equal to t minus 1. So bring this here, this will be minus 3 plus 1 is equal to t. So we have minus 2 is equal to t, which is our final answer there. Is the changing of this. When you interchange the denominator and the numerator, then the base itself must carry a negative power. That's the index law. So those are some of the things you have to take note of. So that's all for today as far as index notation part 4 is concerned. And mind you, we'll be releasing part 5 together. So part 5 will consist of questions from Y, clinical, and jump. So that's what part 5 is all about. And that part 5 will be the complete task of our work. So those are some of the things I want you to take note of there, and it will be something also if you can easily follow up. So we'll be having a complete session soon. Thank you for watching. I appreciate your patience. We have 35 subscribers now. Please help us tell your friend, let them subscribe. There are more for them to learn. So thank you. God bless you. We love you all. And don't forget, we handle both maths, physics, chemistry, further mathematics, and computer. Thank you.